All right, Crouton Ramon's House of Math, little lesson on precalculus. That's the y equals mx plus b that you see in the title of the video. So, what was I doing with this student? For those of you that are supposed to be trainers or aspiring trainers, can you tell we were practicing our 6 multiplication tables and adding 5. Okay, I'm going to break the rules of presentation right now. There's all this stuff on the board. When you are presenting, especially to small children, one thing at a time. This should be the only thing on the board so that they aren't focused over here where they see 11 and they think thoughts like, well, I'm 11, and so on, right? Or my sister's 2, and they start daydreaming and they miss what you're talking about. Focus here. All the rest of this we'll get to in a minute. But just to make the point, you need to verbalize what's going on in the subconscious mind. So here, in the subconscious mind, I can see an equal sign. Oh, that 5 is older than most of you watching. Let's see here. Oops. And then my piece of clay came off. This is just Play-Doh that I'm using to stick it to the whiteboard. And let's see here. It's a girlfriend hair. All right. So what do we have? We have 5 and 3 is 8. That's obvious. But what's not as obvious when you're fooling around with these is also that 8 is the same thing as, 5 is the same thing as 8 minus 3. And 3 is the same thing as 8 minus 5. There's 3 facts there, not just 2. 5 and 3 is obvious, but the other 2 also. Just remember, there's 3. So 8 is the same thing as 5 plus 3. 5 is the same thing as 8 minus 3. And 3 is the same thing, right? Super easy. What are we doing? Fooling around with 8s? We're talking about little, small, young children. You need to verbalize what they're doing. Okay, and since this child was playing with 6s, well, let's put the 6 in there and talk about 6 compared to 8. And see, what we're going to do is we're going to add 5 to a bunch of different numbers here. And when I started out, this is where we ended, not where we started. We started with a smaller one, which was y equals 2x plus 3. But same thing here. Oh, we can see. Oh, look. Well, they can see it. Right? It's not just symbols. They can see that 6 really is 1 more than 5. And if I have a 6 and I want to figure out how much more 6 needs to be 8, well, it's 2. It's not going to be 3. And again, 6 and 2 is 8. 8 minus 2 is 6. And the last one, of course, is 8 minus 6 is 2. Or whatever order you want to put them in. But don't just do 6 plus 2 is 8. Okay. You have to verbalize it for the students. All right. Now, on this one, if you're watching this, 1, watch on 2 times speed. That usually helps. And 2, you may want to get your blocks out and play along, because I'm going to use symbols. But if you get your hands on the blocks, this is going to become completely and utterly obvious. And speaking of utters, it's Moocau. We're going to go to Moocau's Doughnut Factory. Yay! All right, so what do you want to do? Do you want to play blocks and have a good time, or do you want to teach them math lessons? Well, a lot of you want to teach them math lessons, and you don't feel qualified to teach them math lessons because you're not a math teacher. You're, quote-unquote, just a mom. That always cracks me up. The most important job is just a mom. Okay, so if you look at this here, we started off with just this piece of information. We started off with 2 pieces of information. I'm going to tell you the story. And we're going to present it like we're presenting for little children. What are we doing here? We're practicing 6s and we're practicing adding 5s. That's what we're doing. But actually, we're going to practice 6s and adding 5s by doing some calculus. Well, pre-calculus. Linear algebra. Or linear calculus. Okay, so here's the story. What we have is Moocau. And Moocau, I got a donut factory. What he has is a donut factory. And he's trying to figure out what's going on in his donut factory. Or we can tell it where you have a donut factory and Moocau comes over and spies on you. Or you want to go spy on Moocau, but you don't get there in time. And what I always say is Moocau, it's Moocau. So he doesn't show up at 0 hour. So we don't know if there are any left. Because the question is, how many donuts are they making per hour? And were there any in there to start with? So were there, and we'll call this cases of donuts. So we know when Moocau got there, he comes back with this information. He says after 3 hours, there's 23 boxes of donuts in the factory. And after 5 hours, see, if he would have come the next hour, it'd be a lot easier. And if he would have showed up before they started, it would have been easier. But he doesn't show up till 5 hours later, and then he goes out and has a nap and comes back, and he figures out that after 5 hours, there's 35 boxes of donuts in that factory. All right, we don't know this. I'm giving you this ahead of time. So how do we figure out that this is why the formula is the number of donuts is 6 an hour plus 5? Well, let's figure this out. Here's the last part of it. This is the dy dx right there. And you can clearly see the difference. And you can see that the difference in between this one and this one is, 12, right? 23 and 35. The difference is 12. Look, we're doing math. We're doing subtraction. And the difference between 3 and 5 is clearly 2. And if the whole thing is 12 and one side's 2, then our rate must be 6. But we're not going there immediately. That's the way it was more or less explained to me. dy dx. I'll never forget it. I was in, what was I? I was an 11th grader. That was junior year before they showed me this. The child that I was playing with was 10. Okay, so let's figure out how to get here. I'm not going to give the full-on, if you want the full-on explanation and training, go to Module 2 or get more training. But here I'm just going to explain a little more briefly, because I'm not going to get the blocks out. In the other ones, I get the blocks out. You are going to get the blocks out. So here's what we're going to do. We're going to figure out, let's express one number in terms of another, because that's what we're doing with calculus. It's the study of variables. It's the study of how one variable affects another variable. So how does x affect y, and how does y affect x? Oh, and here's another thing we explain. This is x, this is y, and if there was a third one, this is z. Right? X, Y, and Z. Doesn't matter. You're in Russia. This is X. This is Y. You're in China. This is X. This is Y. You're in Brazil. This is X. This is Y. Anywhere on the planet, this is X, and this is Y. And another thing, and one more thing. It's length times width. It's not width times length. And if you put the third one in there, it's length times width times height. Right? To get the cube. Get a three-dimensional character. But it's length times width. And what we have here with Mortensen math is length multiplicand width multiplier. And you'll see this in a second. We have some syntax that's agreed upon in the mathematics. So let's talk about this one. And see, this is a hard one to start off with because there's so many combinations. If you start off with something like 2x plus 3 and a couple of numbers, then there's not going to be a lot of combinations. So on this one, and that's another part of the presentation, is that you start with small numbers. Start with something like 2x plus 3. Don't start with 5x or 6x plus 5, but we worked our way to 6x plus 5 because it was going to reinforce the lessons that we had been doing on sixes. We've been counting by sixes. We counted all the way to 120 and so forth. Now we're going to multiply by any number. But first we have to figure this thing out. So get out your threes and figure out that, look, and I'm just going to draw it again. And I'll make it over. Let's see, can I see? Yeah, you can see easily. All right, so you get out these guys. How many of these are contained in 23? What's the most amount of threes I can count out of here? Well, I can count 7 of them. So I'd have 1, 2, I'm drawing threes. I don't have a pink pen. Actually, that's a lie. I have a pink pen, don't I? He said, looking through his pens and not seeing a pink one. I had a pink pen, but that pink pen, it has flown the coop. It is not here. There's a purple pen, black pens, green pens, but because I want a pink pen, there isn't a pink pen. All right, never mind. We'll just stay with my happy orange pen. All right, so 3, 6, 9, 12, 15, 18, 21, and then there'd be 2. Okay, get your blocks out, I mean it. Or at least draw along with me. All right, so that's 7 of them and 2. Or it could be 1, 2, 3, 4, 5, 6 of them, and well, how many would you need? You need 18. You need 5 more. 1, 2. Oh, look, there's the 3. Right. It's going to be added to the 2, and now I'm going to have 5. Oops, let's just do this. 1, 2, 3, 4, 5. All right. Then it could be 1, 2, 3. All right. This is tedious. This is why we're going to go to dy dx. But we want to play with this a few times. And if you have the Moocau in there, or your Doughnut Factory, this can be fun, right? Just, let's make all the combinations. And it's fast and easy. And you're going to run out of 3s, is the other thing. So you're going to need 2s and 1s to make these. Or you're going to need to get out 7 3s. How could you get out 7 3s? Well, you could get out 7 3s like this after you played with the 3 blocks, because you run out. Okay, so then you could replace these guys over here and then use the 3s. But anyway, all right, so what do we have over here? Over here we had 7 and 2, and then 6 and 5, and then 5. Well, let's see, 5 3s is 15, so we'd need 8. 1, 2, 3, 4, 5, 6, 7, 8. Let's see here. And then we're going to keep going. Right, and until we get down to the point where we'll skip here, right? Because you're going to make all the combinations. Why? Because we're counting with the little children. Your child needs to be able to count by 3s, and this is good practice when they're 6, 7, 8, 9, 10 years old. All right, so then the last one, of course, would be 1 3 and 20 over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But you do all the combinations. All right, now let's do the combinations for 5. And I'll make the combinations for 5 in blue. Get out your blocks. All right, so this works out nicely because, look, it could be 7 of them. 1, 2, 3, 4, 5, 6, 7, and none. But it can't be this, because we're looking for some similarities between this one, and it can't be that one. What if I did 1, 2, 3, 4, 5, 6, and 6 times 5 is 30, and then I'd had 5 over here. 1, 2, 3, 4, 5. Oh, we're done. Because I can see that this has 6 and 6, and this has 5 and 5. So those are the rectangles we want to deal with. And this says that they make 6 an hour, and then there's 5. Right? So over here, they make 6 an hour, and then there's 5. Okay, so let's see if it works. 6 times 3 is 18, plus 5 is 23 for sure. 6 times 5 is 30, plus 5 is 35. So it's these two. Those are the ones. So now you can take them and put them on top of each other, and you can see, what are we doing? We're going to be going the other way now. We're going to turn it so that they're not on top of each other. So these are not 5s. We'll put them like this. All right. So these are not 5s going this way, but 5s going the other way. So in other words, we have 6 this way. And then we can see that if I go up 3, this whole thing is going to be 18. I'm going to draw it. Like I said, you're getting your blocks out. And actually, all you need to do is pick your blocks up and turn them sideways. All right. So there's that. Okay, 1, 2, 3, 4, 5, 6. There they are. Oh, wait, and then I need the 5 over here, which is what you saw in the beginning. So there's 1, 2. Oh, geez, that's a terrible 5. All right. Let's make it nice. There you go. That's a 5 block right there. It's supposed to be. It's my drawing of a 5 block. All right, now I'm going to use another color so we can clearly see the dy dx. And I guess I'll use orange. So there was 3 of them, and then to get 5, we need 2 more. Okay. So what do we have here? We have 6 by 5. You see your distributive in there? That 6 times 5 is the same thing as 6 times 3 plus 6 times 2. And then we add the 5 more. But anyway, what we have there now is we can clearly see the difference in the total number, which is 35, which is your y's, and your 23, the difference is 12. So let's just make that box right here. Now the whole thing is 12. And for some reason I'm having a hard time. Yeah, see, it's like, it doesn't, even to me it doesn't look right. All right, I'm out. Yeah, that's better. All right, if the whole thing is 12 and one side is 2, the other side must be 6. Simple as that. Now, what are we doing? That's the dy dx. The difference in y's over the difference of x gives us, well, it gives us slope, it gives us rate, it gives us a whole bunch of things. It gives us the change, obviously, because that's the change. Okay, but we're not going to talk about dy dx in the first lesson. He didn't hear any of this. He didn't even hear y equals mx plus b. We just figured out that it must be the number of donuts, y, is the same thing as the rate, which is 6, times however much time we have, which is the x, plus 5. But again, I didn't bring in y equals mx plus b. I just brought in this and talked about, well, what's the m? Well, that's the dy dx. But we didn't talk about that. We just talked about the fact that the number of donuts was the same as 6x plus 5. And now we can figure out all these other numbers. At 0 hour, if I put 0 in over here, there were 5 boxes of donuts to start off. After 1 hour, well, see, and then the child has to do the math. 6 times 2, right? Plus 5. And it turns out that that was some math for, right? Even, especially when we got up here. Especially when we start getting higher. That he needed work on his 6 multiplication tables, and he needed work on his addends. So we go back and play some more. We're going to go back and play box and build stuff and build towers and play around and get to the point and listen to the multiplication of rock songs. So then it's easy to multiply by 6 and add 5. You see, because a lot of high school kids have a hard time multiplying by 6 and adding 5 because they don't know their 6 multiplication tables. So then it even becomes more difficult. The degree of difficulty is higher. The cognitive load is higher. Anyway, 1 times 6 plus 5, 11. 2 times 6, what's that? 12. And then 5 more, right? And see, what are we doing? We're adding 5 to various numbers. So what are we going to have there? Is that going to be okay? Is the 12 and 5 is going to be 17? So we added 6. We added 6. We added 6. He saw that pattern immediately. All right, what's 4 times 6? 4 times 6 is 24, plus 5 more is 29. And lo and behold, 23 and 6 is 29. And there's our next one, that information that we're already given. So then we can start figuring out. Above all, mathematics is predictive. So what happens after 8 hours if everything stays the same? Well, after 8 hours, then I got to do 6 times 8 is 48, and 48 plus 5, 8 and 5, and 3, because I did it over here already. Let's see here. Did I? No, I didn't. No, so let's see here. I got to figure out my 8 and 5, so I got to know my addends, right? So 48 and 5 is going to be 53. Oh, look, that's kind of fun. Palindrome. So we can calculate. And then we can go the other way. What if they, let's see here. Let's say I put, what number do I want to put in there? Well, let's just do, if I know over here, let's make a different problem over here. What if I know the number of donuts, but I don't know how long they were working, but I do know this. So now I'm going to know the y, and I'm going to say that that's 47. Well, how do I figure out what my x is? Well, I can do some algebra, and this is the way some of you were taught. Oh, let's put this over here. 47. And we don't know what that is. All right. Some of you were taught to do some algebra over here where what do? We want to solve for x, so we want to isolate x. So first thing we're going to do is 0, 0. And we're going to have y minus 5 is the same thing as 6x. Well, I don't want to know about 6x. No fun, get back to 1. So what I'm going to do is I'm going to divide everybody by 6. And now I know that 1x is the same thing. And I guarantee you this doesn't help. Y minus 5 over 6. If you just do it this way. What you want to do is have them figure out, well, how do I get back to my x? If I know that it's, well, what I'm going to have to do is I'm going to have to divide that number by 6, and the most amount of 6s I can get out of there would be what? 6 times 7 is 42, plus 5 is 47. So this must be our 7. And again, you can explain that by fooling around with the blocks. And the other thing to do when they're little is I'm just fooling around with pens and doing some drawings. You've got to get the blocks out and do 47 and then cut that up into 6s. And then if you cut 40s, the most you're going to be able to count out is 42, and there's going to be 5 left over. Oh, look, we're forced to do division. So what are we practicing here at the Doughnut Factory? Which is the point of this lesson. The point of the lesson was not to teach you the Doughnut Factory story. The point of the lesson was to point out that what we're doing here is practicing addition and multiplication and division. You need all those skills to be able to go to Mooey's Doughnut Factory and figure out what was going on, right? So what do you want to do? Do kids want to learn y equals mx plus b? Do they want to learn pre-calc? No. What do they want to do? They want to play. They want to play. That's what they want to do. They want to play. All they want to do. When they wake up in the morning, they want to play. And then you call them in for lunch, and they don't want to come in for lunch because they're playing. They want to play. And then you call them in for dinner. No, Mom, we're playing. Hopefully they're playing outside, not on the computer, but whatever. They're playing. They want to play. So what do? You play. Play with blocks. That's what you do. It makes math fun and easy. And see, with this child right here, I'll let him tell you about it. All right, so what we had... Hey, Mr. Hand. But no, it's Muay D, Moocau. What we had here was a child that was practicing his 6s and 5s, right? Adding 5s and multiplying by 6s. But see, adding 5s over and over again, that's multiplication. And over here we see, we added 6 again and again and again. But these aren't on your 6 multiplication tables. This is just adding 6, right? If I started out with 6x plus 6, this would have been a total lesson on multiplication, because then it would have been the 6 multiplication table over here. But I went with 5 because we were practicing 6s and 5s. But do you see how the point of the lesson is to play and practice? And then we found out that, yeah, this was a lot of work for the 10-year-old. So what are we going to do? We're going to make it so that it's not work. We're going to make it so that multiplying by 6 is easy. And we're not just going to do 9 of them. We're going to do 12 of them. No, we're going to do 20 of them, so that he knows all of his multiplication by 6s all the way out to 20. And then adding. This is why we play with the addends. This is why you see me spending so much time with addends. And for some reason, they seem to have left addends out in the curriculum. In fact, most of you hadn't heard the word addends until you met me. They got to know their addends. Because addends, that's the first one to master. And then after that, multiplication. And then after that, stuff like this is easy. Because I've had it where I've had teenage girls. True story. We do all this complicated algebra. And then we finally get it down to 8x equals something like, 135. And they can't do it. They can't figure it out because they can't divide. And it should be easy in here to figure out how many 8s is in there. And we could do it the long, hard way. 135, and then I put 8. How many 8s are contained in 135? Well, let's see here. I know that there's got to be at least 1 8 in 130. There's got to be 10 of them in there, because that's going to be 80. Or you can do it the other way they explained to you. Well, there's 1 8 and 13, which is exactly not what's going on. And then they put an arrow over here and make me insane. That's 10 times 80. And 10 times 80. Okay, see, and look, now we got to do some more math, and they got to know their addends. Over here, that's a gimme. But making that a 5, right, by just adding 2. And then I know we're done there. Okay, now how many 8s in 55? Well, I know 7 times 8 is 56 if I know my multiplication tables and I've been playing around. If I don't, I'm going to have to count the hard way. And count 8, 16, 24, 32, 40, 48. Oops, that's as high as I can go, because if I add another 8, I'm going to be more than, right? So what is that? That's 6 of them. So 6 times 7 is 50, 1 too many. So now what? We have 48. And get this down. Oops, we got the reflection from the computer. And there's going to be 7 left. So the answer is X is the same thing as 16 and 7/8. And we could turn 7/8 into a decimal, but you know what? This is a really good answer. And we'll stop there. But the idea being is that teenage girls not being able to, when they get to this part, they fumble because we do all the algebra and they can do the 0, no fun, get back to 1, but then they can't divide. Or then they can't multiply. And if you had known your multiplication tables, by the way, all the way out to 20, you'd know that 16 was close to 135 because you know your multiplication tables. But most of you don't. So you're not going to make the same mistake with your children. You're going to give them 45 addends and 20 by 20 matrix is what I was going to say. 400 math facts will make math easy. All right, that's pre-calculus. Don't let them fool you into thinking, because my website has mostly games and activities and, well, that's not true. There's all kinds of lessons on there. But I try to tell you to teach with games and activities. Teach with games. Fool around. Before you get to this, and any child can understand this, don't let them fool you. Practice your multiplication tables so that it's easy. Practice your 45 addends so that that's easy. Right? And the ones you need the most are 9s and 10s. 9s and 10s, 9s and 10s. All right. And like I said, if you just watch this, this could be confusing. But if you got your blocks out and you got your hands on it, it's easy as pie. And you'd be able to see that all we did was turn these this way and turn these this way and put them on top of each other. Right? You'd be able to take your blocks and literally put them on top of each other and see and get your hands on the dy dx. The difference in the y and the difference in the x is right here. And we can see clearly that, what is it, the first 2 pieces of information we got were this one and that one. That's why I wrote them in different colors last time. So let's do that. We didn't have that. Oh, and we didn't have that. And we didn't have that. Those are all numbers we found. We did have that. And we didn't have that. And that was a whole other one that we didn't do. So we had this one and that one. So I can see the difference between 3 and 5 right there. I can see it. I can point to it. I can put my hands on it. I can put my hands on the 12. That's the difference between the y's. And then I can clearly see that must be 6. The rate must be 6. All right. We form rectangles to facilitate counting. This is a quick and easy lesson. Again, I wouldn't do this with students. If I had students, they'd be getting their hands in the blocks, and it would have taken us a lot longer to do this. Now, for a lot of teachers, they just bust out the formula, right? And they're supposed to, from this right here, right? Once they get the formula, once you've handed them y equals mx plus b, they're supposed to figure it out from there. Oh, look, here's the formula. Right? I can guarantee you that doesn't help. What's the m? Well, the m is the difference in the y's over the difference in the x's, and that m can be the same thing, as I started out in the beginning, as slope, rate, change, but that's what the dy dx is. It's that m. It's this right there. And that's what we spent time doing. And then once we get that, we can figure out that. Now, I've had students that just looked at this, right? Genius children, and I've had the privilege of working with several of them whose IQs were way higher than mine. And they just look at that, and they look and they see, y equals 6x plus 5. The kid was like 7 or 8 years old. And I was like, okay. Actually, we started off with an easier one, and then I gave him a harder one, and then I gave him an even harder one. Now, let's do a super easy one. So that's a stretch. We started off with 6x plus 5, which is a big number, but why don't you go back and do a problem like this, where y equals 2x plus 3. Keep it small. Makes it simpler and easier for the child to work on. Ooh, it's not very legible. Let's make it big. You guys do y equals 2x plus 3. And the way you do it is you talk about Muay's Doughnut Factory. Don't start off with 0 hour. And just pick a random number from, say, 1 to 8. And we'll go with 4. After 4 hours, how many cases or boxes of donuts would be in the factory? Well, 4 times 2 is 8 plus 3 is 11. And then let's come back after, 7 hours. 7 times 2 is 14 plus 3 is 17. Oops, it's not comma. All right, so that's the information you're going to give them. You're not going to give them this. They're trying to tell you this, and it becomes a game with the slightly older students. I give you the ordered pairs. You have to give me the formula. And then later on, we can make a game where I give them this number, and they have to figure out that number. So one of the first things we say, well, how many did they start off with? Don't know. Let's see here. If there's 23 donuts in the factory, how long have they been working? Or 23 cases of donuts in the factory, how long have they been working? So again, it becomes a game. Right? And what are you going to do? You're going to express one number in terms of another number. And see, with this one, where we had all those combinations, where it was 3, we were expressing one number in terms of the other, and you had all those 3s. Well, over here, you're only going to have 2 4s. The most it could be is 1 4 and 7, 2 4s and 3. That's it. We're done. Over here, it can be, see, you can't even get the 3. It can be 1 7 and 10, or 2 7s and 3. Oh, look, we already solved it. But get your blocks out to figure it out. That's why you keep it small when you first start off. So there's only a couple of combinations that we can see, oh, look, there's similarities between these 2 rectangles and what's left over. They both have the same amount of leftover. They both have the same kind of, so then we can figure out, right? Anyway, do this on your own. CroutonRamonsHouseOfMath.com for more. But the point of the lesson is we were practicing 6s and adding 5s. That was the point of the lesson. We weren't going to the Doughnut Factory to learn y equals mx plus b and to be able to derive an equation from a set of ordered pairs. And in fact, we're not going to derive any kind of equation. We're going to derive an equation in slope-intercept form from a set of ordered pairs. And then we're going to graph it. But we're not going to do it all at once with a 10-year-old or a 7-year-old. We're going to do it in small stages. This might be the first one. And then we go do something else. We just do one problem. Or you could do 3 or 4 problems and then go do something else. And then next time you add more information. And then next time you add more information. And then next time you get to the point where you're graphing it. And then next, right? You take it in baby steps. The way you eat an elephant is 1 bite at a time. All right, CroutonRamonsHouseOfMath.com for more.